So hi everyone, today we are going to solve a problem called merge to BSTs. So the problem is given two BSTs, return elements of merge BSTs in sorted form. So here we have given two BSTs. There the root node is 5 and the its children are 3, 6, 2 and 4 and the other BST is that root node is 2 and the children are 1, 3, 7 and 6. So and also we have given the constraints is we need to solve this problem and in on time or log time according to this constraint. So now this problem. So we have given our BSTs and we have to return the BSTs, element of BSTs in the sorted order. So in the BSTs, there is one property of BSTs that the left node is always smaller than the root node and the right node is always bigger than the root node. So according to if we use this property, we can use Inorder to sort this tree alone and also sort this tree alone only. So how to and we can try to merge these sorted trees and we can get our answer. So this is one of the way to solve it and how to and now how to go the Inorder Traversal in this tree so that we can solve this problem. So the way to Inorder Traversal in this is the following. So here we have I have taken the two tree which have different nodes 5, 3, 6, 2 and 4 and in the another tree which have nodes like 2, 1, 3, 7 and 6. It's the given is first example. So now we can check we will take this tree to see how can when we do Inorder traversal in this tree. So the way we do Inorder traversal is we first go to the left of the tree, then we see the take the root node and then we go to the right of the tree. So this is how we can traverse the Inorder traversal in uh, in a BST or in any tree. So now how to do Inorder traversal. So we can for doing the Inorder traversal tree, we can take the use of the stack, which will help us to do the Inorder traversal this tree, and also we can take the use of an array. And in where we will store our value after after we will get the answer. So how can do we travel this tree? So first we will go to the root node. So and we will store it in the stack, and then we move to the left according in order array in order traversal. So we move to the left. So we store this value and we move to the left again and we store this value too. So now we according to this we will again move to the left, but the tree is exhausted now. So and we found the null value. So when we found the null value, so we will just move to the root again and store this root value to the array. So we just come here and store this value in the array. Now after storing this value, after storing the root, we will move to the right of the array. So we will move to the right of the 2. So right of the 2 is n, and and there we exhausted the right subtree also. So we then move to the so if we move the the right subtree, so we check the stack. Now the top of the stack is 3, this node. So we will go to the this node and we will just move this node into our where we are storing the values. And now we will move to the right of this tree and you know because we have the right of the subtree and we will go to the 4 now and we will store it in the stack. Now we will check the left of this subtree. Then left of this subtree is none. So if the left of the subtree is none, then we will just in this tree is exhausted and we will store code in our memory. Now and now we try to go to the right of this survey. So there we have also exhausted this survey, right survey. So we just move to the 5 and we just move it from here and we store it in our array. Now we have exhausted the left its lesser tree completely. Traverse this lesser tree completely. Now we will try to reverse its right subtree. So we will now go to its right subtree and store 6 into the stack. Now after storing 6 into a stack, and we will try to go to the left of the subtree and we will found that we have just exhausted the subtree. So we will move to the 6 again and we just store this 6 to our array and then we move to the right of the subtree and we found also there is also an null value. So we just move to the stack and the stack is also empty. So we have completed our Inorder traversal and the output of the Inorder traversal is sorted as a sorted array of this sub 3, 2, 3, 4, 5, 6. We can also see a code representation of the solution. So there we have we have in this Inorder traversal we have the group of the strings in none. So we just return the none value. Otherwise, we will go to the left. And if the left tree is exhausted, then we will return none here. And we just store this data and we will then move to the right of this tree and we just do it recursively to solve this problem. We can do it also do it in the iterative way and get the same answer. And now after completing this in the first tree and second tree, we will we store the sorted values in the root 1 and the root 2 array. And now we can just traverse these array like uh, if like there I have traversed it and try to find the smallest value if the root 1 value is smaller than the root 2 value, then we just store it in our final array. And if it is not, then we store the root 2 value in our final array. After doing this, we will just see if one of them is exhausted, then we have just get out of this while loop and just append all of the other arrays value in our final array. Yes. That's how we solve this problem. Mm, but there is one problem with this approach is like let's analyze this the time complexity for this. So if we try to analyze the time complexity for this array, so first of all we need to traverse this one whole. Even time complexity here is like um, order of h of n, sorry. And then we have to traverse this tree with, and their time complexity is also order of n. Traversing both of the tree, we will just merge this. So uh, there we also have to use order of time complexity to at least order of maximum. Let's say it's m and it's n, so we have to use order maximum of m comma and actually minimum, we can say at maximum, yeah, we will do that maximally, because we have to first travel the till the minimum and then go to till the maximum to find the remaining values in the array. So we just have to do that. And also we will getting the space complexity as n plus n, and to store a as maximum of also m plus n. N plus order of n plus order of, so there we got our space complexity to store all the values in the array, and there is our time complexity to store all the value to find the sorted array of these BSTs. So we can use another approach to make this time complexity little smaller, and our execution will be faster from that. So it is the another approach. So another approach we can use is uh, we can use iterative solution to traverse these tree at once, and we can travel together, and we can just uh, do the traversal. So the traversal time will be the O of h, O of n, and storage will be merely O of h. So let us see how can we do this. So what we can do, we can try to take two stacks. Like let's say we can take like one stack as t1 and another stack as t2. So after taking these two stack, we can also take the array where we can store our sorted merged values. So now how to solve this? So we can just take this and relatively just store this in the array. So that first you can go through this and store these in the array. So let's say to store this root array start from, we can start from here. So let's say we have stored this value in our stack one. So what can we do? Well, like we have, let's say we have stored this 5 in here, then we can store 3 in here. We can move left to left, to right, to to do the Inorder traversal, and this tree is exhausted, so we can just stop here. Now we can try to uh, mm, try to traverse this one. So let's say we have traversed this and still two in here, and then one in here. And now we have also exhausted this tree. So now what we can do, when we have exhausted the two, three, we can take the top value from these two, and we can have two, and we can have one here. We try to compare these values. If this value is smaller, and this value is smaller than this value, we can just store this value in the array. So let's say we have stored one in the array, and we can just remove it from here, and we can just traverse it to the right. And there we have found we have not null value, so we just do not do anything, and then go for another run. Now we try to compare these two values. These two values are equal, so we can take one of those values. So let's say we have taken this two, and so we need to remove this value from here, and we can just store this value in this array, and we can move to the right in this array. So now there is we have found that it is also valid, so we can just do anything and compare these two values. Now we try to compare these two values. So we have found that we have a smaller value in stack 2. So we just remove this and store the smallest and small value in the array, and then move the right for this node. So we have moved to the right of this node and store the value 3 in the stack 2. And when we have stored this value, and we can move to the left of it, and we have found null here. So we have exhausted this, so we can do anything, and then we just compare the top values of it. So just we try to compare the top values for it. So let's say we have taken, so if they are equal, so let's we have taken this top three. So then we take this and we traverse and right to it, and move traverse right to it. So now we need to store 4 here and go to left of it. So now then we go to left of it. It also exhausted. So we will just it is exhaustion. We can compare these two values, 4 and 3, which is smaller, 3 is smaller. So we just remove 3 from the stack 2, and we store 3 into the sorted array, and go to the right of this 3. So the right of this 3 is 7. So we just store 7 and move to the left of this 3, 7, according to the number traversal. So and we this we can store 6 in here, and then we move to the left of this, and we have exhausted in this. So we just start comparing again. We will compare this 4 and 6, which is smaller. The 4 is small, so we just store 4 here and remove from here 4 from here, and we try to go to the right of this Now we try to do the right always, and it is exhausted. So we just compare the values, top values again. The top values are 5 and 6. So when we compare these values, so 5 is smaller now. So we just remove 5 from stack 1 and store 5 in the array. Now, when we have stored 5 in the array, we need to traverse to the right of this. So we are trying now. We will find 6 and we just store 6 in there. Now we will go to the left of this, and the left is n and null, and it is exhausted. So we just start comparing. So when we do compare, so we have found the 6 value, we and these are equal. So we have taken the 6 value from stack 1 and store it in the in this array, and try to do the right, go to the right of it, and we have found that it is also exhausted. So we will do nothing, and now we have exhausted this whole. So now what we can do is we can traverse this fully. So what we it is so we can take this 6 and we can store it in here. Now now we need to traverse the right of this 6. That the right of this is none. So we just yeah, we just go to the top. We just go to the top of this stack. So now the top of the stack is 7. So we uh, just store the 7 in here, and we go to the right of it. In the right of it also um, exhausted. So we have exhausted of all of our stacks, and the sorted array we have gotten from this two BSTs. So let us see in code how we can solve this problem. Okay, so if we try, yeah, now we have to take as I've shown you that I have taken an array in which we will store the sorted values, and two stacks where we will store the where we will store the uh, elements of our trees. So the ST1 is the stack one, which will store the elements of this root one tree, and ST2 is the array which will store the elements of this root two tree. So what we have done here is we will do a while loop, and we will check if ST1 and ST2 is greater than 0. That means its length is greater than 0, and also root 1 and root 2, they should be in they both should be not null. If they if all of these values got false, then only the value will be stopped. So now we will just traverse through our first tree, and go to the left of it, and until we get the left of it as null. So we store these values in the ST1, and also we will go to the left to the right tree, second tree, and we will go to the left till we will not get none. And after we will get none, we will go to the next step, and we will just pop the top element from this stack like this, and we have just store then we have just compared its data. And now this statement is because if let's consider if our first list is exhausted. So this is exhausted. So this statement will work like if list 1 exhausted, then on we will directly go to the list 2, or if list two is exhausted, we will just go to the list one. We will not check this. So this is because of that here. So now we will just store our, when the list one data is more than list two data, we just store that in the our final array, and we just move to the we just go to the right of root one, because the LST1 is the data of root one, and we have done the operation with the first tree. So now, and we will just we have I just store the popped element back in the array, because we need to check it again with the another element in the another in this st1 array. So now, after doing this operation, we will just get our final answer, which will be stored in our array. So now if we try to run this code, here it is. So we will get our output correctly, and all of the test cases will be passed. So now, how to about the time complexity. So the time complexity will be nearly, let's say, we have gone through every element of this array, and we have uh, we have traversed every element of both of the arrays. So the time complexity for both of them will be order of and what about the space complexity? So what we have done is we have gone through, we have stored the height of the tree for the first one, plus height of the tree for the st1, plus height of the tree for the second one. So we can say let's say it's h1, and height of the second one is h2, and it's, and also we have stored all the elements for h1 and h2 in our final array. So we have just reduced our also reduce our space complexity as well as our time complexity a little bit. So thank you, and please like and subscribe.